Docker is one of the hottest buzzwords right now, but it's not just a buzzword, it's actually a way of life in the development world, okay? Maybe it's not the most popular buzzword, AI is the most popular buzzword, but Docker is up there. And in this video, I'm going to give you a quick crash course on Docker itself, even though this is more about QA. I have learned Docker at step 6 of my 8-step process to become a QA automation engineer. So why is Docker a big deal? Because it's a game changer. It's more than a buzzword, like I say, it's just a way of life. It is a tool that every software development uses right now. Every developer, every DevOps, every company is using Docker. It's a tool that came up and that made things a lot easier to work with. It is basically giving you like your own little server. People that know the depth of Docker are going to argue it's not. But for us to visualize it, we're going to visualize it like a server. And I'm going to get into that. I'm going to give you a quick tutorial on that. As a QA, the knowledge of Docker is what's going to take you from a QA automation, like a basic QA automation, to an SDET, software development engineer and test. It is the base for everything you do. You have automation, right? You have front-end testing, which we did in step 3. Then you have back-end testing. Now you are a QA automation. Then you want to get into the next level, which is SDET, software development engineer and test. And Docker is the foundation for that. Why Docker is a game changer? Well, Docker is just not a buzzword, like I said. It is a way of life in this world, in this development world. And Docker is what's going to make you different than just a QA automation, right? You have QA automation and you have SDET, which is like the next level, software development engineer. And Docker sets up the foundation for that SDET process. And I put Docker at step 7 or step 6 of the 8-step process because by now you are an automation engineer if you do the first 5 steps. And now you're going to go into the next level. So you're going to start with the foundation of the next level, which is Docker. It's just an awesome tool. I talk a lot about Docker, so people think I'm DevOps, even though I'm an automation engineer. That any engineer that works in development needs to understand Docker. And in this video, I'm actually going to give you a little crash course so you can understand what it is and what makes it a big deal. All right. And the reason I say it's a foundation is because the foundation of CI/CD, and all SDETs are required to know CI/CD, right? You have automation engineer and you have SDET. If you look at every job description, they're going to talk about CI/CD in one way or another. And the next step, right? Step 6 is Docker. Step 7, I'm going to create another video, is CI/CD. We're going to get much more into depth of CI/CD then, but I'll explain what it is here briefly. So let's do a quick crash course on Docker. I'm going to use the actual slides I used in my Docker course. So as part of my program, the Access Pro, where you get access to everything, there is one of the courses is Docker, because my program is to get you into SDET. You start from basic Python, Selenium, API testing, SQL, all of those courses in the program. And then there's Docker, and then there's CI/CD. So this slides I'm about to talk about, I literally took the same slide that is in the course. I'm just going to briefly talk about it here just to give you the concept of Docker. What is Docker? Why is it such a big deal, right? Because Docker is just really awesome. You don't have to be an expert in Docker, you just got to know the basics. And Docker is one of those things you don't continue to learn. Once you know, you just use it, right? Like Python, for example, you continue to learn it. It will never stop. You're going to have to just get better at Python, write more code, practice, and things like that. Docker is a little different. Once you know how to use it, you just keep using it, right? It's not a lot that changes. You don't need to practice a lot. Once you get the concept, you just keep reusing it. So it's a really great investment of time, because once you get it done, you get it out of the way, you can always talk about, oh yeah, I know Docker. So Docker, this is just kind of like an official definition, but Docker is an open source platform that allows developers to build, deploy, and run applications in containers. So it says developers to build, right? We're trying to be SDET, or QA automation engineer SDET. SDET stands for software development engineer. So we are developers. So it allows people to build applications, and we are writing tests for those applications. So our test itself is an application. We are writing code, so it's going to allow us to package our code in a certain way. Also, if the application we're testing is using Docker, it really makes a big difference if we understand Docker, so we know how the stuff that we're testing works. So here there's a definition of about containers and something more. We'll come back to the slide because without talking about it, it won't make a lot of sense. So let's go to the next slide. So let's look at how applications work, right? Let's say you have just a simple to-do app, like a little website, right? It's a web application. So Docker is typically for web applications. I'm sure it can be used for other things, but it's server-side technology. So when you have an application that you want to run, let's say you work for a company that builds to-do apps, right? That's the application, is the to-do app. That app needs requirements. Let's say it's a Python app. So let's say we have a web application A. It has a requirement of Ubuntu, which is an operating system like Mac OS, Windows, right? Ubuntu is a Linux, a version of Linux, a flavor of Linux. Let's say you need an operating system, which is Linux and Ubuntu specifically. You need Java 11. You need Tomcat, which is another thing, a web server. You need a framework called Spring Boot for Java. You need a certain amount of memory. You need a certain amount of CPU, right? That's what your application needs when you design it. Then you have another application that needs the same thing, Linux, but a different flavor of Linux called CentOS. This is a Python application and it's old school. Let's say it needs Python 2.7. It needs Nginx. It needs Django. It needs this and needs that, right? And we have a third application. It has its own requirements. It needs CentOS, the same thing, but it needs Python 3.11 specifically. It needs Nginx, Django, and blah, blah, right? So those are 3 different applications, 3 different software, 3 different websites, right? And they have their own requirements. So when you want to run this, what do? You're going to rent a server somewhere in the cloud. Back then, they used to rent it, like they just literally buy a physical server. Now, you're going to rent a server somewhere in the cloud, and you're going to make sure that server has everything you need to run your application. In this case, let's say you want to run application A, right? We need Ubuntu, Java 11, Tomcat, Spring Boot. So you're going to rent a server and you're going to install those things. You're going to install Ubuntu, you're going to install Java 11, you're going to install Tomcat, you're going to make sure you have a Spring Boot available. Whatever you need to do, you're going to configure that. Then if you have another application B, it needs Nginx, it needs Django, blah, blah. So you're going to get another server. You can do it on the same server, it's a whole different topic. But let's say you get another server and you're going to set that up. You're going to install everything in there, right? So normally the way it works is you work on all this on your laptop as a developer. The developer builds it, tests it, it would run it. It's called local, right? You run the application locally. Once you're done with it, you commit your code into Git. Some process will happen and that code makes it to the server. And there's a different team. Usually there's a team called DevOps or release management, like different engineers that you tell them what your application needs. You're going to say, hey, I need a server that has, so let's say we're doing application A, we're going to tell them, hey, I need a server that has Ubuntu, that has Java 11, Tomcat, Spring Boot. I need all of those things and set that up for me. Because you set all that up on your laptop, the application works on your laptop. Now you time to make it available to the server so the users can use it, the public can use it, whoever your client is can use it. So you tell the DevOps people that they set up the computer or the server with all those things, then you put in your code in there and it works, right? Then what happens is all of a sudden it doesn't work, right? It works on your laptop. When you put it on the server, it doesn't work. Then you're going to say, but it worked on my machine. That's like a common thing that people used to say, but it worked on my machine. It works here, same code, you put it on the server, it doesn't work. Or even something that was working, you make a change here, you make an update, then you take your update, put it up there, it doesn't work. You're going to say, oh, but it worked on my machine. So Docker will solve that problem. The problem that says, hey, but it worked on my machine. So what Docker does is going to package everything in one piece. So here, what we're looking at here is analogy. It's actually, people say this is actually the source of Docker, or the concept of Docker came from this. So I'm going to tell you a little story about this. Shipping containers, right? So even in Docker, container is a big word we use, containerize. When we talk about something is Dockerized, it's using Docker, we say containerize, run a container. So the idea is back in the days, before these shipping containers were invented, manufacturers, business people would package their stuff differently. Some people would package it in a box. Some people would package their stuff in a barrel. Some people put it in a bag. There's a name for it. I forgot what this is, carrot or something like that. So different people package their products differently. And when you ship it, the trucking company, the shipping company will need to handle all those things, which is a nightmare, right? Because to handle a barrel, you need a different kind of machine than to handle a box. So the shipping companies and the trucking companies, they need equipment to handle this kind of stuff. Different packages, different equipment. So it's a nightmare. It's very expensive. It's not scalable. So one time, some guy that owns a trucker, Alexander something, if I don't mess up his name, I should have prepared that. It's an American guy who owns trucking companies. He invented basically a shipping container, right? The shipping container that you and I know. So he said, I don't care how you package your stuff. I don't care what you manufacture. Just put it into these big containers, right? Exactly this specific container. Now I have a machine that can pick those up and just move around, load it into the ship, load it into the truck. I just have equipment that can handle that. I just need one equipment to handle no matter what you do. So it's up to you to package all your products into a container. We don't care if you do it in a barrel, in a box, in a bag, whatever you do inside. I don't care what's inside. Just make sure, you put it inside in a way that's not going to break and it's going to work for you. But for me, as long as you give me a container, I can handle it. I have a machine every port, not right? If you go to any port, I live very close to Oakland port and Los Angeles port. Every time you walk around, you drive around around there, all you see is this containers. So every port all over the world, they have machines that can handle this port. So all you need is a machine that can handle the port, the container, you'll be able to ship your product. So that's what Docker did. Docker allowed us to create containers. We call them containers, or they're actually images. We'll get to that. It allows us to take everything we need. Like let's say this application needs Ubuntu, Java 11, Tomcat. We put all of that into an image, like in one big piece of thing, right? And now all we need is a computer that has Docker. So we're going to ship this whole thing, the image, put it into that computer that has Docker installed, and it works everything. So there is no more, but it worked on my machine. If it worked on my machine, it's going to work there. Guaranteed, right? Almost guaranteed. So what Docker allows us to do is take all those things, all the dependencies. Those are dependencies for our application. The application needs Ubuntu, it needs Java, it needs Tomcat, blah, blah. The developer is going to write, there's a way to do that. It's going to write instructions, and it will create an image. We'll create an image, put the image somewhere. So now when you tell the DevOps people, hey, I need a server, the only thing they have to do on that server is make sure Docker is available on that server. Then your application, you're going to package it, put it into, it's called a registry. You register it basically. And then you take that image and you put it into the new server that has Docker, and that image has everything you need. Hopefully that makes sense. So I'm going to give you another example that makes it easier to visualize that. People really love this DVD analogy. Very, very easy way to understand it. I know these days people don't use DVDs, but if you're as old as me, you definitely have used DVD. So at least you understand what a DVD is. A DVD is a disc. You go find any DVD player, you put it in there, it will play. Right? The same video, whether it's in my DVD player and your DVD player, it's going to play the same exact movie. The way the DVD works is inside of the DVD, there's a lot of files. There's a video file, obviously, right? There's an audio file, obviously. There's more things. There's a menu and navigation files. There are subtitles. There are some copyright protection files. So there's a bunch of files that are packaged in the DVD. Now, the people like, let's say Sony or somebody that builds movies, they package their movie, all the files, the video files, audio files, everything into this disc, right, into the DVD. Now, for you to play the movie, all you need is a DVD player. So you take that disc, you plug it in, you put it into the DVD player. It doesn't matter what brand DVD player you have. It doesn't matter like anything about the DVD player. It will play. Right? So that's what Docker allows us. It will allow us to create a disk, just like a DVD, that has all our files, all our application, everything we need in there. And we're going to go and just put it into a computer that has Docker installed, and it would work just like the DVD player. The good thing is you could control certain things about that application. The application, the code is the same, but using environment variables and things like that, you can control it. Like in a DVD, when you play a movie, you can watch it in black and white. You can watch it in color. You can watch it with the volume up, with the volume down, right? Those things you can control. Same thing with Docker. When you have your application containerized, when it's running, just like when you're playing the DVD, you can control, hey, which database does it connect to? Does it work with dev environment, test environment, production environment? Which options does it has? That way you can deploy the application, the same code in different environments. Let's say you have a test environment and production environment. So test environment is the version of your application that you test, that the general public doesn't access. Production is the version of the application that the general public, your client, access. So normally we'll talk about this in the CI/CD. That's what CI/CD is. You put it into this test server, the public cannot access it, then you test it. Now with Docker, everything is packaged. So the code you put in test and you test it, right? It's the same image. You're going to go and put it into production. So after you test it, there's no chance of new bugs, new issues being introduced. The same thing you tested, the same exact thing goes into production. So that's what Docker makes life a lot easier. There's two ways to use Docker. You use it to run an existing application. Let's say you're testing an application and you need to run it. If it's Dockerized, you're going to use Docker to test it. That's one way to run an existing application. Even outside of the context of testing, if you want to run some kind of application, let's say you want to run a MySQL, you want to run a WordPress, any kind of application that you want to run, any software you want to run, instead of installing it directly on your machine, if they do support it, you can run it with Docker. Will keep your computer clean because Docker does not install anything. You install Docker once and the rest of it is just like a file that you're going to have, like an object, like an image that you're going to have. The another one is you write code, you have your own code, then you Dockerize it. Whatever code you wrote, in our case, we write automation code, test code, and we make it so it will run in Docker. So two ways, run an existing Docker container or take your own work, your own code, and make it run in Docker. Okay, two ways to use it. So when you learn Docker, you're going to learn all these commands. There's no point in talking about them right now, but you're going to do Docker images, Docker PS, Docker RMI. It's a terminal. There's a UI for it. I don't recommend you learning the UI. You will see if you ever take my course, you will see I want you to use the terminal, because in the real world the UI is not there. In Linux environment the UI is not there. In the real world 90% of the time you work I made up that 90%, but most of the time you work in a Linux environment, so UI is no bueno. Okay, all right, so that is what Docker is. That's a little crash course. Hopefully that gave you an idea of what Docker is, its role in CI/CD. So the next video I'm going to create, your step 7 in becoming a QA automation engineer, is CI/CD. We'll talk more about CI/CD then, but CI/CD is the process of taking the code from the developer and making it available to the public, and there's a lot of process in between. So once you package it as a Docker, you just take it to a server, put it there, test it, take it out to put it on another server, test it, you just move it around as one piece. That's the role of Docker and CI/CD. It's the tool for CI/CD. It's one of the major parts of CI/CD, but we'll talk about that in the next video. So 2 key Docker skill sets: running existing application and Dockerizing your own code. I already talked about that in the other slides. So the learning strategy for Docker, just take a course. YouTube is actually kind of okay for this, as long as you find a YouTube course that has a project, right? So what I just did right now, the crash course gave you a really good idea of what Docker is, what it's used, the concept of it, not how to use it. So even knowing how to use it, looking at the commands and everything is good, but you do need to run it. You do need to run an application. You actually have to get your hands dirty. So if you do join me and join my program, you have a full course part of it. In fact, if you already know Python and stuff, 1 month is free. My program, at least right now, for the first whole month is free, so you can just join and just take the Docker course for free if you wanted to. It's a great course. It has real hands-on projects, everything you need to know. So Udemy is fine for this. YouTube is fine for this. Just find a course that actually has projects. That's the main thing. It's not something like Netflix you just watch, like I always say. It is something you have to get your hands dirty with. All right, so that's how you're going to learn. So next step is clear. Make sure you follow this 8 steps. These 8 steps are really actionable. It makes it really easy for you to know what you need to do to become a QA automation engineer. An awesome career that is in demand, and it will grow in demand. AI, people are creating a lot of software with AI, so all that stuff needs to be tested, and we are going to use AI to test it. Of course, we have to get into AI. There's no doubt about that. But AI is a tool. You have to have the foundation to be able to use this powerful tool. AI by itself doesn't do anything. You have to apply it for something. So you got to get the basics done. So these 8 steps are just perfect steps. This is exactly what I would do if I was starting from scratch. If you want this in a written format, click the link in the description. Go download it. It is on my website. There's a blog post and a PDF. All right. If you don't want the PDF, you can just bookmark the page if you want to. And check me out. If you want to work with me, I do one-on-one coaching. I will hold your hand throughout the whole way and get you to be an SDET, a software engineering test. I also have a very affordable subscription with 1 month free right now, but you can just become an SDET in your own speed. All right, so check that out, and I'll see you on the next video. It will be linked somewhere here on the screen. Step 7 of this process.